Assistant Professor Physics in the Department of Physics, Maharaja Jivajirao Shinde College, Srigonda, Ahmednagar. In our last lecture, we have seen what is voltage divider circuits, and in today's lecture, we are going to see what is current divider circuit. In order to understand what is current divider circuit, one should know what are the parallel circuits. Here is one of the example of or circuit of parallel. Such type of parallel circuit is shown. Parallel circuit is nothing but the branch arrangement of the one or more resistances, two or more resistances which are placed side by side across the common voltage source. What is parallel circuit? Parallel circuit is a branch arrangement of two or more resistances which are placed side by side across a single voltage source. This is called as parallel circuits. Now we will see few of the properties of parallel circuits which will give us idea about the current divider circuit. First of all, when we consider a parallel circuit, then the voltage V, here one parallel circuit is shown where voltage V is applied across the resistances R1 and R2. Their values are mentioned as 2K and 4K respectively, and I is equal to 9 milliampere current is flowing through this circuit. Now, when we consider such type of parallel circuit, then the voltage which is applied over here, the same voltage will be observed through R1 and through R2. Therefore, voltage across R1 and voltage across R2 will remain same, and that is equal to the applied voltage V. Now what about the current value? The current which is applied is 9 milliampere, but as the current passes through this divider circuit, so the current get divided. Current get divided means in case of parallel circuit, first property is that voltage across R1 and R2 is same, and that is equal to applied voltage V. And now what about the current? So the current get divided. Current will get divided, and current, we know that current is nothing but current is equal to V upon R, and here I1 is the current flowing through R1 and I2 is the current value flowing through R2. Therefore, I1 and I2 are different and their values are given by the formula V upon R. In both the cases, V will remain constant. It means that either I1 or I2 will remain upon the values of resistances R1 and R2 respectively in case of parallel circuits. Now, third property is that the value of the equivalent resistance. When we consider a parallel circuit, then value of equivalent resistance is given by 1 upon R is equal to 1 upon R1 plus 1 upon R2. Here only two resistances we have considered, therefore its addition is nothing but 1 upon R, that is equivalent resistance, is given by 1 upon R is equal to 1 upon R1 plus 1 upon R2. These are the few of the properties of parallel circuits. Now we will try to find values of I1 and I2. In order to find out the values of I1 and I2, just now we have seen that 1 upon R is equal to 1 upon R1 plus 1 upon R2. It means that 1 upon R is equal to, we will cross multiply it, R2 plus R1 divided by R1 R2, and hence what will be the value of R? R is nothing but R1 R2 divided by R1 plus R2. This will be the value of the resistance, equivalent resistance In case of parallel circuit, we will require this value many times in order to calculate the equivalent resistance during parallel circuits while solving few of the problems based on it. So R is equal to R1, R2 divided by R1 plus R2. Now, what is the value of I? The value of I is equal to V upon R. Value of I is equal to V upon R. V will remain constant through both the branches and R is nothing but the equivalent resistance just now we have calculated. So we will substitute the value of R, and just now we have calculated it as R1 R2 divided by R1 plus R2. You have to mention it in bracket. So what will be the value of I? I is equal to V upon R1 R2. So V into R1 plus R2, simplifying it, divided by R1 into R2. This is the value of I. Now we know that I is the constant, but we want to find out the branch current I1 and I2. In order to find out the branch current I1 and I2, we will substitute I is equal to V is nothing but I1 R1 or I2 R2. So either we will substitute I1 into R1 into R1 plus R2 divided by R1 into R2. So R1 will get cancelled, and from this formula we will obtain the value of I1 is equal to I into value of I1 is equal to I into R2 divided by R1 plus R2. What we did up till now, we want to find out the value of branch currents I1 and I2. In order to find them, what we did, we know the equivalent resistance for parallel circuits. So we have wrote the formula 1 upon R is equal to 1 upon R1 plus 1 upon R2. Simplifying it, we have obtained the value of R as R1 R2 divided by R1 plus R2. And we know that the current flowing through the circuit, parallel circuit, I is equal to V upon R. V remains constant in both the cases, where V is the applied voltage. So V is equal to I is equal to V upon R1 R2 divided by R1 plus R2. But we know that V can also be written as product of I1 R1 or I2 R2. So by substituting value of I1 here and V here, in case of I1 R1, we will obtain the value of I1 as I into R2 divided by R1 plus R2. In the similar manner, we will find out the value of I2. Value of I2 can be obtained by substituting the value of R2. We will skip this and we directly write down the value of I2 as I2 is equal to I into I2 is equal to I into R1 divided by R1 plus R2. So we have obtained the values of I1 and I2. Now we have to substitute the values of I, R1 and R2 in this respective formula in order to get the value of I1 and I2. In case of I1, we have to substitute value of I. I is nothing but 9 into R2. What is the value of R2? R2 is 4 divided by their product. R1 plus R2. Value of R1 is 2 plus value of R2 is 4. So this comes out as 36 divided by 6 is equal to 6 milliampere. This is the value of I1. Now we will try to find out I2 by substituting respective values in the formula this second. So here I will calculate I2 is equal to I is same 9 into R1. Value of R1 is given as 2 divided by R1 plus R2. R1 plus R2 means 2 plus 4 is equal to 6. So 18 upon 6. So 3 milliampere will be the value of I2. So for this circuit, parallel circuit, we have calculated value of I1 as 6 milliampere and value of I2 as 3 milliampere. Now we will see what is open in parallel circuits. Open in parallel circuit means there is one parallel circuit which is open. When we consider a circuit which is open, so if the circuit is open, then there will not be any connection or wire. Hence, it will have resistance as infinity. Then what about its current? So, current I is equal to V upon R. If R is equal to infinity, then I becomes 0. So, there will not be any current through the circuit. So, for any branch, you will not observe any current, but the voltage that you applied here, that voltage will be observed at the open ends. This is the property of open in parallel circuits. What is the property of open in parallel circuits? When we consider a parallel circuit which is open, then its resistance is infinity. And because of this infinite resistance, its I value becomes 0. And this V we will observe at the open end. Therefore, its value of V is nothing but VOC, output voltage. This is the property of open in parallel circuit. Now, what is short in parallel circuit? Suppose this is one parallel circuit and we make it short by connecting a wire across this R3. Then what will happen? Not only R3 will short circuit, but all these R1, R2, R3 all are short circuit. And because of this short circuit current, we know that short circuit current will have 0 value of resistance. And hence, through this circuit, no current will flow. And because of this, when the circuit is short circuit, then not a single component get damaged due to 0 value of current. This is the property of short in parallel circuit. So today we have seen what is parallel circuits or what are parallel circuits, then how to implement current divider circuit or current divider circuit law. Here we have seen I is nothing but V upon R. It means that current value get divided and hence these circuits are called as current divider circuits. We have seen one of the case open in parallel circuits and another one is short in parallel circuits. Thank you.